Okay, so when it comes to our absolute value inequalities, we are going to have two cases when we get down to the very end. Either we're going to have the case where the absolute value of something is greater than or equal to a number. So let's just think about this for a second. Anytime you're trying to figure out which way you need to shade, whatever it may be, let's think about numbers that are greater than or equal to 7. Well, obviously 7 is equal to that. And any number bigger than that. 8 is greater than or equal to 7. 9, 10, etc., etc. So we've got all these numbers up here on the right end. But we have this absolute value idea, right? So -7 is also the absolute value of that is equal to +7. And then -8, absolute value of -8 is +8, so that's greater than 7. So all of our numbers down here apply as well. So when you have greater than or equal to, you're going to end up with numbers on the ends of the number line. Now, we've been working with interval notation a little bit. Let's express this answer in interval notation. On the left end, you've got -infinity. On the right end, you have +infinity. So if we were to express this in interval notation, we'd be going from -infinity to -7. It was equal to, so we use the bracket. And then we've got +7 to +infinity. Again, we were equal to 7, so it's a bracket to +infinity. All right. What about numbers that are less than or equal to? Okay, let's think about our scenario here with the 4. Now, I'm going to ignore that equal to here for a second, just so that I can remind you. When it's not equal to, we're going to put an open circle there at 4. Numbers that are less than 4. Well, obviously that's 3, that's 2, that's 1, that's 0. Okay, we take the absolute value of some of these negative numbers. They're going to be less than 4 until we get to -4. Okay, so anything between -4 and +4, the absolute value of that is less than 4. In interval notation, this would be from -4 to +4. I marked out the equal to, so we got parentheses on the ends. Okay, so really our steps are the same. I don't think you need to write down these steps. You're isolating the absolute value expression. Now, when you create the two cases, you got to remember something on the one where you change the sign. This teacher, I got these notes from somebody else. This teacher is really clever. Use the KISS method. You keep it, and you switch, and you switch. And I'll show you what that means here in a second, but just keep that in mind, the KISS method. Keep it, switch, switch. Then you solve both of them, and then you're going to graph your solution. So let's look at an example here, okay? The absolute value of x plus 6 is greater than 7. I probably want to start writing it down now, okay? The absolute value of x plus 6 is greater than 7. It's already isolated, so just like with our equations, it's already isolated. We don't need to do anything. We need to create our two cases. So, with our two cases, we're going to keep everything the same for one of the cases. Everything stays the same. For the other case, you keep what's inside the absolute value. You switch your inequality sign, and you switch the number on the other side of the inequality, or you switch the sign. Okay, so keep it, switch, switch. Switch the inequality, switch the sign of what was on the other side. And the reason why we switch the inequality is because we're making that a negative number. Remember the rule with inequalities, anytime you multiply or divide by a negative, you got to flip that inequality, and that's going to come into play here later on. Hi.
What did you do? Enrolled 6 more students for this talk.
Great. We're not hot enough in here already. We're good. Thank you. All right, so solving these two inequalities. Subtract 6 from both sides. So x is greater than 1 is one of our solutions. Subtract 6 from the other one, so we get x is less than negative 13. So x is greater than 1. If we put that on our number line, we got 1 right here, and we're greater than that number. If you struggle with which way you're supposed to shade, just pick some numbers and see if they work. Pick 2. 2 is greater than 1, so that means I need to go in the direction where 2 is. Okay? Negative 13 is over here, less than negative 13. Okay, negative 12 is right there. Negative 12 is not less than negative 13, so I need to go the other way. Okay, so if we're putting this in interval notation, we got negative infinity on the left side, positive infinity on the right side. Negative infinity to negative 13, and 1 to positive infinity, left to right. Okay, everything you do in math, in general, should be left to right. Reading graphs, doing your notation, whatever, always, always, always move left to right. Okay, let's do another one like this. It's already isolated, so 2 cases. 2v minus 3 less than 19. Other case, keep it, 2v minus 3, switch the inequality, greater than, switch the sign, negative 19. Solve your inequalities. Add 3, 2b is less than 22, divide by 2, b is less than 11. Add 3, 2b is greater than negative 16, divide by 2, b is greater than negative 8. Now, somebody may be thinking, I had a negative number and I divided. Okay, I wasn't dividing by a negative. I divided a negative number by a positive number. Okay, it's only when you divide by a negative. If the 2 were negative is when you switch that inequality. All right, so let's look at this. We've got v is less than 11. So 11 is right there between 10 and 12. And v is, so less than, we're going to the left. V is greater than negative 8, so greater than, we go to the right. So we get that overlap. It's between those two values, between negative 8 and 11. All right, I'm going to skip number 3 right now. Let's look at number 4. Okay, let's look at number 4, because I want to look at one with the negative there. Okay. Again, already isolated. So 2 cases. Keep everything the same for the first case. Keep everything inside the absolute value. Switch your, I don't know why I dropped the equal to. Switch the inequality. Switch the sign. So 7 minus 4n is greater than or equal to negative 27. Subtract 7 from both sides. Negative 4n is less than or equal to 20. Divide by negative 4. So n is greater than or equal to negative 5. We divided by negative, so we flip that inequality. Other one, subtract 7. Negative 4n is greater than or equal to negative 34. Divide by negative 4. N is less than or equal to, now I go to my calculator. I mean, I should be able to do this, but negative divided by negative is a positive. They're both divisible by 2, so that's 17 over 2. Now, we are putting it on a number line, so if you don't know that 17 divided by 2 is 8.5, then of course use your calculator so you can correctly place that on your number line. But n is less than or equal to that 17 halves or 8.5. So less than, left. N is greater than or equal to negative 5. So negative 5 greater than or equal to, so we go to the right. So our interval notation here, negative 5 with a bracket because we were equal to. And again, I prefer fractions, but if you prefer or decimals, that's fine. You can leave it like that.